All right, so these are going to be the notes on basics of matrices. The majority of you have seen this before in Honors Algebra 2, but if you were in college prep Algebra 2, I don't believe you've ever seen this before. So that could be a little world rocking, but know that, I'm here to help. If you need extra help, I'm happy to do it. We have 3 targets we're aiming to hit today. First one, I can add, subtract, and multiply matrices. Those are our basic operations. Number 2, I can find the determinant of matrices, which we need to accomplish target 3, which says I can find the inverse of a matrix. So our purpose today, doing this so that you'll be able to solve systems of equations. It's another way to solve systems of equations. That's a big way that matrices are used. When we see them, they're a way to organize data. So we are going to see them by hand with little examples. And then eventually I'll show you in the calculator how to do bigger problems where they can save time. This is not something that you will use in calculus next year. This is more something if you go into a pretty heavy math using field, you'll take a class called linear algebra where you do like all matrices all the time. Is a very normal thing. So this is the look at how can we use them and tie them to what we're doing now. All right, so welcome to matrices. A matrix is a rectangular array of numbers written within brackets. Meet matrix A. Matrix A is a 2 by 3 matrix. It's called a 2 by 3 matrix because it has 2 rows and it has 3 columns. It's going to be really important as we look at this that we're always going to name a matrix. We say the rows first and then the columns. When we do matrix multiplication, we're going to use it again, rows and columns. When we name a specific part of a matrix, we state the row and then we state the column. So that's going to be really important. So rows, remember, side to side, columns up and down, like the columns on a porch. All right, so that's a matrix. Really, it's like a table. So we use it like a table. It organizes. When we do systems with matrices, the variables don't go in the table, just the coefficients do. So it simplifies it. It strips down to just the numbers. All right. And again, this is going to be the overview. If you find that you need more than what we do today, we can make that happen. All right, office hours or at the end of class. So if I want to use that idea, and you do not need to feel like you need to write this huge matrix down, I'm going to tell you the size of matrix B. So it says, what are the dimensions of matrix B? So when I look at this, I look for the rows. There are 1, 2, 3 rows, and there are 1, 2, 3, 4 columns. So matrix B is a 3 by 4 matrix. All right, rows, then columns. Matrix C, I want you to think, but not write down, of what size matrix C is. I mean, you could write it if you wanted to, but just hold it in your brain for a moment. All right, you should be thinking 1 by 4. Were you thinking 1 by 4? So 1 row, 4 columns. Even though there's only one thing in each of those columns, it still counts. You can also name an element in a matrix. So if you want to say specifically like, hey, that one, here's how you can do it. You can write, see how it says A and then has a sub 2 and a 3. Again, rows, then columns. If I say A2, 3, what's the element in row 2, column 3? And it's that 2. Okay, that's just an idea to say where you're going. Okay, so when we talk about these rows, then columns, for the size, if we want to say where something is, again, rows, then columns. So what we want to do now is we want to get that first target. We want to look at the basic operations. We're going to do most of them in just one problem. Then we'll spend some time with multiplication because it's a little trickier, right? All right, so basic operations, some thoughts to keep in mind. When you add or subtract matrices, all you have to do is add or subtract the corresponding elements. So they do what you think they would do. The matrices do need to be the same size. The only way it works is if they're the same size. And if you want to multiply by a scalar or a number, you just multiply it times each entry. You just distribute it. So adding, subtracting, and multiplying by a scalar are all going to behave like you think they should. Even if you didn't know what a matrix was, you could probably guess your way through this one. When we get to actually multiplying two matrices together, I don't think that's the case. All right, so let's look at all three of those ideas with this problem. All right, take a moment, write down this problem. We're going to find the difference, 5a minus 3b for matrix A and matrix B. I want to show you how straightforward multiplication with a scalar and subtraction can be. All right, ready? So we're going to do 5a minus 3b. So I'm going to do 5 times matrix A. So 2, 3, negative 7, 1, 4, 5, minus 3 times b, which is 3, 0, 6, negative 1, 8, and 2. That negative 3, I'm going to make it plus a negative 3. And when I multiply that 3, I'll be going ahead and distributing the negative with it. If I was just subtracting two matrices, I think it's the best idea to give out the negative so that you don't mess up those signs. This is another chance to practice our precision, being really careful with these entries. All right, so I'm going to multiply by 5. So really just distributing it to every element. So I get 5 times 2 is 10. 5 times 3 is 15. Times negative 7 is negative 35. Times 1 is 5, 20, and 25. I'm going to add to that. Now I'm distributing a negative 3. So I get negative 9, 0, negative 18, 3, negative 24, and negative 6. Last step, I add them. That looks like just adding the things that are in the same spot. So 10 and negative 9 gives 1, 15 and 0 gives 15, negative 35 and negative 18 gives negative 53, 5 and 3 gives 8, negative 4, and 20, no, 19. Right, that's pretty basic, yeah? So adding, subtracting matrices, no big deal. Multiplying by a scalar, no big deal. They do real normal things. What gets funky with matrices is now going into multiplication, right? So here's what we need to make sure about multiplication. It says that the columns of the first matrix must equal the rows of the second matrix. So this is not going to be a, hey, they have to be the same size. This is what has to happen. The columns of the first have to equal the rows of the second. I'm going to show you an easy way to check for that. My brain doesn't want to memorize that sentence. The doing is much easier. So go ahead and write down for yourself those two matrices. And let me show you how we multiply them together. All right, so how we check for this to be true, columns of the first and the rows of the second, we write the size of each one. So first matrix is a 2 by 2. Second matrix is also a 2 by 2. So what you check for that rule is that the insides match up. As long as they match up, you're good to go. They cancel out, so think of them as canceling. And your answer is going to be what's left over. So the answer is going to be a 2 by 2 matrix. So nice, easy check there is that the middles have to cancel. As long as they do, you're good to go. So now I'm going to have a 2 by 2 matrix as my answer. So I'm going to set up for you the answer matrix. So I'm going to have 4 blanks because it's a 2 by 2. And I do that because I want to show you what goes in each spot. How do you decide how to fill in those blanks? So just like naming the side, we are rows and then columns, right? So if I'm aiming for this first spot here, I'm going to use, it's in the first row in the first column. So I'm going to use the first row and the first column. I'm going to do -1 times -3 plus 0 times 5. So notice how I'm working my way across the row and down the column. -1 times -3, 0 times 5. All right, look at the next one. If I'm aiming for here, top right, I'm in the first row, I'm in the second column. So I'm going to use the first row, the second column. I'm going to do -1 times 3 plus 0 times 0. Is this ringing bells? All right, we come down here. All right, down here we are in the second row, first column. So second row, first column. 3 times -3 plus -4 times 5. All right, take 30 seconds and see if you can fill in that bottom entry. All right, it's second row, second column. So we use second row, second column. 3 times 3 plus -4 times 0. Our final answer, we just do the math. So -1 times -3 is 3. And then the 0 times 5 goes away. For this one across, we get a -3. We get a -9 and a -20. So -29 and 9. There's our answer. All right, especially for people seeing this for the first time, any questions to clarify about multiplication? Anybody have a question? What just happened? All right, let's do another one then. All right, so go ahead and write this out, and we'll do this like half together, and then I'll have you finish it. So write down the problem, and then go ahead and write the size on top of each of those matrices. All right, so we have a 3 by 2 and a 2 by 2. Okay, so we make sure that the insides match up so they cancel out. And our answer is going to be a 3 by 2. All right, so I'm going to set up 3 rows, 2 columns. All right, first entry. I mean, if you're good to go, you can start working. I'm going to talk through the first 3 and then let you finish the rest. So first element is going to be first row, first column. So I use the first row, I use the first column. So I'm going to do 2 times 8 plus 3 times 2. All right, still working across the row, down the column. For the next element over here, I'm in the first row still, but the second column. So first row, now second column. So I do 2 times 0 plus 3 times negative 5. All right, let's look at what happens when we go down. Here now we are in the second row in the first column. So now we have to use the second row back to the first column. So negative 1 times 8 plus 8 times 2. All right, go ahead and test yourself. Do the last 3 and get a final answer matrix, and we'll go over it. I want to give everybody a chance. So if you're already done, hang tight. All right, so let's see how we ended up. So I'm sorry, my pen, like my writing doesn't look great. My board is not pleased right now. So first elements, we just had to make them look nicer. So we have 16 and 6 gives us 22. We have a negative 15. We have an 8. Then we come to the ones where you were trying. So negative 1 times 0 gives me 0. 8 times negative 5 gives me negative 40. At the bottom, we have 4 times 8 is 32. And then the last element is 0. All right, so I think a good question came up last year, which is how much work do you have to show, right? You need to show more than nothing. You don't have to show everything I'm showing. So I think a good kind of in between is if you want to write, instead of what I have, if you want to write 16 plus 6, negative 8 plus 16, 32 plus 0 to show how you multiplied, that would be fine for work showing, okay? Don't go just straight to the answer, show me something. Really that helps me know how you got it, and then it also helps with finding a mistake, if you have a mistake, right? So I want you to try this next one. Do it on your whiteboard so I can see it, whether you're at home or here. Try this out on your whiteboard. See how it goes. This is, I would say, really like the funkiest thing we do today. So if you feel good about this, you're doing good. All right, here's a nice example of kind of the middle of the road work, right? Where you're showing something about what you did. Looked really nice. So check your answers, looking for, each element to be right with a 19, a negative 12, 14, negative 12, and 18, negative 15. Right, any questions about multiplying? All right, so, building the background that we need to be able to solve systems, we need to be able to multiply. We also need to be able to find inverses. So that's going to be our last piece is finding a determinant and an inverse so that we can solve equations. You do not have to write this one down, but I wanted to show you, you can write it down if you want to, just what it looks like to have a problem that doesn't work. So when you look at this problem, to me, it feels like it should work because they're the same size, right? But when you write out what size they are, all right, this is a 3 by 2, this is a 3 by 2. So a 3 by 2, another 3 by 2. When you look at that middle, it does not match up. That means it's not possible. So if you get a problem like that, you don't even have to do it because you can't, right? So that's what it looks like. So just so that you know, it's not something, adding and subtracting, they have to be the same size. Multiplying, you're always just looking for those insides to match up. All right, here we go. Determinant time. Get ready. So to find the determinant of a 2 by 2 matrix, it says if we have the matrix A, B, C, D, to find the determinant, we do AD minus BC. That is the first diagonal minus the second diagonal. So the determinant is just a number. You get a number. And what it does is it allows you to find the inverse. And what's kind of cool is this seems to me, teaching it to you, like pretty arbitrary. Why is that? What someone asked third period, what is the determinant actually? So I did some look it up. It's like, no, it's really just a number that you can use to find stuff. That's what it basically was defined as. So the determinant is going to allow us to find the inverse. Again, the inverse is going to have a little trick that seems kind of weird. What's so cool, I think, is when you see it come together. When you solve a system and you see like, oh, wow, you do these weird tricks. But then when you multiply it out, it actually gives you what you should get. It's pretty cool to see. So here we go. We're going to find the determinant for this matrix. All right, a notation that you might see. So if I ask you to find the determinant, I could just write DET. But just so you know, that's the same as Looks like absolute values. That means find the determinant also. So just so you know, those are both notations for that. So I just do the first diagonal, 8 times 3, minus the second diagonal, 7 times 2. 24 minus 14 gives me 10. Again, middle of the road work, least amount of work I want to see. If you write 24 minus 14 gives 10, that's all right with me. So it's just a number, but it's a number that's going to allow us to find the inverse. All right, take, the 30 seconds and find an answer for that. You at home, shoot me the answer in the chat. All right, so don't let the fact that it's easy let you rush and make a mistake, right? So just be careful with your signs. You do -6 minus -5, and you get -1. So just be careful, right? So the last thing we want to do to get this background complete is find an inverse. So here we go. So last thing, inverses of 2 by 2 matrices. You're going to see kind of 2 options. I'm okay if you just want to pick one to write down because they really say the same thing. You can only find an inverse if the determinant is not 0. And then to find the inverse, you do 1 over the determinant. And then you switch your first diagonal and you change signs on the second. So you pick what of that you like. Our original is A, B, C, D. Ugh, that does not work. I would probably make yourself a note. I wish I could write in cursive because I think my board would like it right now, but I can't. I can sign my name and that's about it in cursive. So from our original A, B, C, D, if you notice what's happening, first diagonal, they're trading places. Second diagonal, they change their signs. And this is where that seems so weird. Like you think about why is that the inverse? I don't know, it just is. But then when you solve an equation and you see that it actually works out to give you what you could solve with substitution, it's pretty cool to see how the numbers interact together. All right, so that's our inverse. So we need the determinant, 1 over the determinant times switch diagonal, change signs on the second. All right, let's see it for this one. All right, you do you. If you like to set it up like the formula, that's fine. I like to find the determinant first. So I'm going to do the determinant. So -2 times -4 is 8, minus 10 is -2. All right, there's my determinant. So I'm going to do, to get the inverse, A inverse is going to be 1 over -2. I'm going to multiply it by, so here's where I'm going to switch the first diagonal. So this is going to become -4 here, -2 here. And change the signs on the second. So this is going to be -2 and -5. All right, you are multiplying that in. What I like to do, instead of writing another step, is just like here, I'm going to divide -2 by each of these. when we end up multiplying, we don't typically want to do a lot of reducing, but I'm going to reduce here because it would look weird if I didn't. So 2, 1, positive 5 halves, 1. All right, when you're ready, last problem for your whiteboards. Find me an inverse.